So let me introduce to you how we can do some basic motor control functions in the CCW workbench. CCW workbench, as I'll post in the description below, two good videos on how to download it and access it and how to work with it. The nice thing about it, it's free. You can create a Rockwell account and download the software directly from their website. Let me turn my light on. Sorry, I forgot to turn my light on. There we go. That might be a little better. And and the nice thing, you can get a simulator, an emulator from it. Okay, this is their new like kind of small micro setup, but I'm going to show you how to start a project from scratch, how to set up the emulator simulator, and how to do some basic motor controls and tagging in this video. So this is the CCW, or Connected Components Workbench Standard Edition. Okay, you can download it. Look for a little icon like this in your file tree. And once you start, go to new, and you can create a new program. And I would call it, I'm gonna call this motor, just because of my sense of humor, Sister Christian. Because my favorite song is Motorin. I know, I'll stop. So hit create, and it's gonna create a program. In the next part, you're gonna identify your hardware. Okay. This is what has replaced Drive Explorer, so if you need to set up a VFD or something like that, this is how you would do that. But we're going to go under Controllers, and we're going to go under the Micro 850, because under the Micro 850, there's a simulator, and it's this one right here. Hold on. This one right here. So... sorry, I was trying to get my draw feature on and I didn't accept the hotkey yet. But it's this one right here, okay? And there's going to be a little extra step to worry about, but we'll worry about that in a second. It's version 12, so make sure this only really works in version 12, so I hear. I could be wrong, but I hear it's only version 12. So let's add that to the project, okay? And so this is what it looks like. So before you do anything else, here's what I would recommend doing, okay? Up here in this is your simulator buttons, and up here is this. But the first thing I would do is just start simulation. Hit the little play button here. And this is going to come up because here's the important thing. Unless you know where your IP address is for your computer, you won't know what the IP address is for your simulator. It automatically defaults to the IP address you're using for your computer. So if you hit the power button, the simulator shows up, okay? Be wary, though, if you have an older computer or possibly slower computer, this will take up a lot of your resources. So I wouldn't use the simulator a lot, just once you turn it on, test your program, turn it off. But get this IP address, and I would go over to RS links, okay? And what I would do is, because it may not find it automatically, so what I would do is, knowing what that IP address is, I would create the little snake. I hit the little snake, which is your configured drivers or your connection. And what I would do is go under here, under available drivers, and put Ethernet devices. This allows you to kind of set up a direct link to an Ethernet device. Hit add new. It's going to be called ABE2. And I would type in that Ethernet address as you have it right here. So 192.168.1.11. In my case, yours will be different. So whatever is right here. So add new, hit apply, okay. And now this will only pick it up if the power for the simulator is on. So right now the power isn't on. So if I'm going to hit the power button, okay, you can see it running right here. Let me go back to RS links. Let me hit close, and under Ethernet 2, and hit the plus sign, I should be able to find this, and there it is, Micro 850. Before you do anything, make sure that's there. Okay? So once that's there, I can close out RS, I just minimize RS links, don't close it, because sometimes with Rockwell, if you close out RS links, it gives you an error and you can't communicate. So just keep it open, just minimize it, okay? And in this case, everything's there. I can keep the power on, but now let me minimize it. So a couple other things. Up here under theme is default and logics. If you're used to compact logic or control logic, I would switch to the logic theme, because everything is a little bit different wording-wise. It works the same, but it's a little bit different. So examples like variables, those are the same thing as tags. Okay, so if I say variables, think of it, or tags, they're interchangeable. And global means controller tags or override tags, and you'll see some other things in a second. So, but I would switch that to logics. It'll come in handy in a second. Default would work too, but I would just go to logics because that's what we're used to. And if I go into global variables, you'll see how we do I/O addressing in this. Okay, and you'll see it's a lot easier because it'll just say IO underscore embed DO dot and whatever the bit is that you're working with. So if you look here, I have up to 27 inputs and 19 outputs. Okay, and look 0001. Do you think we've hardwired this stuff in before? So I'm sure you're aware of it. But here's my bit information, and look 00 on all the way through. Okay, here's one nice thing you can do right now. See here under aliases. And you can do this in control logic, but I may not have showed you that yet. Just go right in here. If you want to make this motor, you can now give it an alias so that you know exactly what it is. So I recommend doing that before you set up your program, so it makes your programming easier. So indicator light 1. Let's just give ourselves another indicator light 2, and you can... and so on and so forth. These are my outputs. It says DO 00. And what do you think DI? DI is your inputs. So I'm just going to call this PB1, PB2, PB3. Let's just roll with it. And I'll just throw in a limit switch. LS1, LS2, for instance. Let me just do, and maybe I'll just throw in motor 2 in here too. Call that motor 1. Motor 2. Got it. So I just gave aliases. So like some of you guys go have nicknames. Instead of typing in the full legal name, now I have a nickname. I can call these things to pull things up easier. And I can identify it in the program a lot easier than trying to remember this exact address. Now here, the next thing I would do, and I would save a lot only because this is a resource-heavy program. Let's right-click on Programs. And this is where you create your program. And I'm going to add a ladder diagram, okay? If you do it, you can program in the other ways, but you might not have learned that yet. So go to ladder diagram. So, because that's what we're used to programming with. And you'll notice it looks very similar once we get there. So I've opened this. Local variables are what we call our program tags. And something else that we can do eventually is we can start adding our own like little bits that we can utilize. So instead of having physical hardware that attached, I can do memory bits. And by doing that, all I got to say is mbit 1 and make sure it's a bool. Okay? mbit 2, make sure it's a bool. I can even do this with like numbers eventually. We'll get to that. So try value. We're not going to use this, but I can call that a dint, and there it is. Okay. So we might use this, and I can even do dimensions, which we'll deal with another time. I'm not going to go into arrays yet, but I got memory bits that I can utilize in my program. So now I can go in my program and now I can start programming. And look, XIC, XIO, OTE, they're all there, okay? Branches, rungs. And now we can just drag what we need down here wherever we need it, okay? So if I want to add a rung, I can do that down here. And now I can bring in my bits. Now, automatically, it's going to come up with a variable selector. You can utilize this. I'm going to close this out for the time being because I want to just get my logic in. But let me just get my logic in. And we'll explain this in a second. But again, all right, there's my basic logic, and I can go in and put my addresses in. And I can just type in PB1, and look, there it is, PB1. and I can type in PB2. Now, I'm assuming here that this is a normally closed stop button, meaning power is going to the stop button. Okay, let's just, this is going to be a normally closed stop button. This is a normally open push button. Okay, bear with me. So let's talk about a little bit about motor control. Up to this point, we've kind of not done anything with, we've said inputs are always on one side of the screen, outputs are always on the other side of the screen. Well, remember though, these bits here only say read the value in this address. So if an output, can I read the value whether or not an output's on or not? Yeah. And up to this point, we've had to hold in and keep buttons on in order to keep things going. So if I want a motor, and if I want to just push a button once just to seal that in, I can still put that out there to control it. But as it stands right now, if I didn't have this here, and let me just, I'll delete, we'll just assume that this isn't here. Maybe here's what I'll do. I'll hide it so you don't see it. Okay. With this normal branch like this, the way it would set up is I would have to hold one push button in while the normally closed is closed in order to keep that motor running. Do we want to pay someone to sit there and hold that all the time? Nope. So what we have is logic called a seal-in circuit. And all that is branching around what bit we want to be momentary, or what set of bits we want to be momentary conditions, and lock it in with the output bit that we have. Because, and if we go back to, so I'm going to go back to motor 1, and I'm going to just go ahead and put this down here, call this motor 1, because I want to highlight something. And what I can do is say, hey, I'm going to add another rung. Copy, paste. Okay, so what here is, I'm going to just hide these other rungs real fast, so just ignore it for a second. So if I look at this push button right here, it's saying this is, we had this logic called OR conditioning, correct? Where if I break it out, this PB1 or motor 1 and PB2 will turn on motor 1. So when it's initially off, what is the condition of motor 1? It's off, correct? But once I push that push button, and as long as this push button is still de-energized since it's normally closed, that motor bit's going to turn on. And the minute that turns on, what happens in this bit right here? Does it go from false to true to false? Or false to true? Is it true or false? It's true. So now it's saying keep this on, and it will stay on. The danger you have to have, and they call this a seal-in circuit. The danger with this, with seal-in circuits, is right here. You always need to have a bit or some way to drop the seal in. Because if this bit wasn't here, once I hit push button 1, it's going to keep motor 1, keep the motor on, because, and there's going to be no way to drop it off. Because you're bypassing that push button. So be aware of that as you're programming. Always have a way to drop out that seal in. And also now, maybe I'll do that over here. Do it over here. Also now, look, I can take the status of that bit and then set up 2 different indicator lights. Let me change this. So I meant to change this to indicator 2. Okay? So motor running or not running? Because isn't this saying when the motor is running, turn on this light. When the motor is not running, turn on this light. So oftentimes I need to figure out when a process is running or when it's not. And so now I have my basic program. I would hit save, save early, save often. And now what I need to do next is build the program. In other PLC program systems, it's called compile. When we use a control logic setup, when we do download the program, it automatically compiles, so we don't have to do this. In this case, we got to hit 2 buttons before we download. So let's hit compile or build, and it's going to build all the program, build all the tags, build everything for us, so it's in a nice, easy packet to transmit. And if you have errors, it's going to tell you right here. And look right here, it says successful, no failed, no up to date. So if you can't download, look here, see if you have failed and what issues there are. And now I can download my program. Except I need to first establish a connection path, okay? So as long as this is on and it's powered on, I can go here to the little setup connection path thing, and I can look for my connection path. I hit browse, and that one I just set up, there it is, RS links. Hit OK, and now it should give you a connection path right there. Okay, and so now you download. And again, it's going to give you if there's issues or not. It's going to tell you. I wouldn't keep the simulator on long, only because if so I'm going to download with project values because it is resource heavy. And it's downloading. And see, everything is successful. It's going to ask, it said everything was successful. Now it's going to give me an option to go to from program to run mode. Download's complete. Do you want to change to yes? And now I'm going to pull this up, kind of put it down here. Or off to the side here. I think I can go off to the side. And it's going to pull up my ladder right here. Okay? And notice when it's red, that's energy. So in green, think of green in the compact logic setup. So I'm going to just push this button, and you can see now this is live. Okay? Blue is bad, red is good in this case. And you notice this bottom rung here, and let me hide this. This bottom rung here is live, and notice bit number 2 is on. Okay? And so once I hit this push button, I'm going to just hit it and let go. Okay? I'm going to hit it and let go. And notice, power goes through this rung, turns on this motor bit. Now that motor bit keeps everything on. I can keep pressing this to him blue in the face, and it can toggle, but until I drop that bit, the bit turns off. Okay? So let me try this again. I'm going to toggle this bit here, or turn on this input. And now I'm going to hit my push button, and notice this light is on, and notice 2 turns on to 1, and now we have 2 outputs on. This is basic motor control, okay? So let me stop this. So I'm going to disconnect. Okay? And what I can do too is I can control a different motor too if I wanted to. I'm going to move this up here. And instead of saying this is PB1, I'm going to change this to PB3. And instead of changing this to motor 1, let me do to motor 2. Let's change this to motor 2. Okay. And now what I will do, just for fun, let me add another rung here. And when motor 2 is on, I'm going to turn on a memory bit, just to demonstrate. Okay, so now build the program. Make sure your communication path is set up. And you can see down here it says build started. Successful, no errors, and now I hit download. So download project values. everything's successful. And so now it's going to ask me if I want to go run mode. Hit yes. You can see it, the little switch goes to run. I'm in run mode here. You can see the little switch goes to run. It's going to switch back over to my program, which is the same as main routine. And let me hide this. Okay. And so now I have my bit on, hit PB2 on, and now look. And you can see the outputs right here too. The motor's on. Both motors are on now. Okay. And let me scroll down here. Just bring that down here. And notice I have a memory bit that's now on. Okay? Because I can use that memory bit to help keep track of things in my program. We'll utilize those a lot more, but that's just a piece of memory. No different than an input or output. Okay? And so now, here's that. I can hit my stop button and both motors turn off. Okay. One other quick thing, let's talk about interlocks. So now that I have this, say I have motor 1's just forward and motor 2's a reverse contactor. If I have both motors running at the same time and both contactors engaged and the motor trying to go forward and reverse at the same time, is that a good thing? No, that's how you burn up motors. So in PLC programming, what we utilize is interlocks, which is just a fancy way of saying XIOs, examine if open. And so in this case, I'll go motor 2, because listen to what the logic will say if I read it out like we discussed. When PB1 or motor 1 is running and PB2 and not PB2 and not motor 2, then do motor 1. All this is a not command of saying when this is not running, put that in there. Okay? So now, if I hit download, let me build and download. It's downloading. Hit yes. And now everything is here. It's in run mode. Let me put my stop bit back on. Do some hiding. Here's my emulator. And so now look at the status of these bits right here. They're both off. So now if I hit PB1, motor 1 is on, and look what happens when I hit PB3. Motor 2 is not engaging because the motor 1 is on, so it can only go when motor 1 is not on. So hit the stop button, turn it back on, and now if I hit this button, notice motor 2 is on. And no matter what I do with PB1, motor 1 is not turning on. So this is a good start. I'll add another video before next week, but at least now you can do some basic programming with motors, okay? I'm going to exit. I'm going to go offline, and that's the same as going offline. And I hope that is helpful to get you started on CCW. Okay? Let me know if you have any questions.